In this video, we are going to continue factoring, and we're going to learn the method called grouping. So we're going to factor by grouping. So how do I know? Because in this lesson and then in future lessons coming up, we're going to learn how to factor. And so we have to know when to use which steps when. So we're going to use grouping method when you look at a problem and there are 4 terms. So 1, 2, 3, 4. So how do I know to use these steps? When there are 4 terms. That's when I use these steps. So you use this method when the polynomial has 4 terms. So cross that out. I had a typo there. So when it has 4 terms in which pairs of terms have a common factor. Okay, so the very first step is to factor out the GCF. So the very first step is to look for a GCF. So we learned how to do this in the previous video. So we look at the 3, the 6, and the 6, and we have to figure out what number divides all of these. So hopefully you're thinking 3 does, right? 3 divides all of these. So that's how I know the first step is the GCF step. They have something in common. Now this has an X, this has an X, this has an X, but this one doesn't. So it's just going to be a 3. So I don't need this much room here. So if this was a pencil, maybe I'd move it closer. So it doesn't have any X's in common. So then I would do 3 divided by 3, so that's 1. And then I'd have the X cubed. 3 divided by 3, that's 1. And then I'd have the X squared. And then 6 divided by 3, that's 2x. And then 6 divided by 3, that's 2. So in other words, what I'm doing is 3 times x cubed would get me this. 3 times x squared would get me this. 3 times 2x would get me this. So I'm factoring this out. I'm factoring out the GCF. Okay, so now let me rewrite that so it looks a little bit better. Okay, so that was the first step. Now the second step is you're going to pair the terms. So I'm going to pair these 2 together and these 2 together. If you want to put these 2 together and these 2 together, you just have to rewrite it. But I always put the first 2 together and then the last 2 together. And then what you're going to do is you're going to do the GCF step again. But instead of the whole problem, what goes into all of them, you're going to just do a pair. So you're going to factor again each pair. So this 3 is going to get brought down. I'm going to ignore it. And then I'm going to ask myself, what do these 2 have in common? Well, if this is x cubed and this is x squared, if this has 3, this has 2, they have 2 in common. So I'm going to put x squared here. And then x squared times x would give x cubed. And then x squared times 1, these 2 would multiply to get this. Now I'm going to do the same thing over here. So what can go into 2 and 2? Well, 2, right? So whatever sign this is, I'm going to bring it down. So I'm going to put 2. And they both don't have x's, so just 2. Now 2 times x is 2x. And 2 times 1 is 2. So that is step 3. I'm going to put 2 together and factor them out. Now, I know if I did this right, if these match. So these should match. So when I factor each pair, I should have these 2 in common, and I'm going to factor that out. So step 4, these should match, and I'm going to factor out the common binomial. So they have both of these in common, so I'm going to take it out. So remember, this 3 just gets brought down. I'm going to bring it down here. So I'm going to bring down the x plus 1 because they both have this in common here. And then you're going to put these two numbers together here. So you're going to put the x squared and the 2 together. And that is going to be your answer. So let's talk about why that works real quick. So the reason why we're going to bring this down is because this is a multiplication problem and so is this. So these two both have an x plus 1 in common. So remember, that always goes in front of the parenthesis, what they have in common. So they have that in common. And what's happening here is this x plus 1 is going to get distributed here with this x squared. Well, isn't that what this means? That this x squared is going to be distributed here? Well, that's what's going on here. This x squared will get distributed here. When you write it as a multiplication problem, it means multiply. They have that in common. So this is just saying, well, why write x plus 1 twice when they both have it, and this means multiplying, and so does this. So then over here, we're going to multiply the 2 by the x plus 1. Well, that's what happens when you FOIL here, when you multiply. So that is why you can write it like that. Now, so again, the F word, right? Factor. The F word means if you take the answer you get, so 3 times x plus 1, and then times x squared plus 2. If I factored correctly, when I multiply this out, I should get this. So let's check and see if we do. So let's check it. So when you're multiplying 3 things together, so I have 3 things together, I do 2 at a time. So I'm going to start with these two. So 3 times x is 3x. And then 3 times 1 is 3. So when I'm multiplying 3 numbers together, when I multiply 2 of them, so that's what I just did, I multiply 2 things together, then I bring down the next one and it means multiply. So I multiply again here. So because this parenthesis, these parentheses here are touching, I know to bring down the parentheses, and this stuff here has to be multiplied with the x plus 2. It's just like regular multiplication. So now I'm going to multiply here. So I have 3x times x squared. That's 3x. 1 plus 2 is 3. And then 3x times 2 is 6x. And then 3 times x squared is 3x squared. And then 3 times 2 is 6. So again, we learned this in the previous video. You're going to take this and multiply it to both of those, and then take this and multiply it to both of those. So this is called multiplying, or it's called FOILing. Okay, so now if we check, if we get the same answer here, we have 3x cubed here. That's what I have here. I have a 6x here. That's what I have here. I have a 3x squared, I have a 3x squared here, and I have a 6, and I have a 6, so it does work. So again, factoring just means instead of this being an addition problem, rewrite this as something that when you multiply it out gives this. Okay, so notice that this was in common right here. They both had these in common. So if they aren't in common, start over and regroup your pairings. So instead of putting these two together and these two, maybe put these two and these two together. And if they still don't match, then maybe it can't be factored by grouping. So to recap, when there are 4 terms, once you've done the GCF, you pair them together. You factor each pair, and if these don't match, then that's how you know this method can't be used. All right, so let's go ahead and try another one, and let's use these steps to try this one out here. Okay, so the very first step is we want to see if there is a GCF. So that is always going to be the steps when you see the F word, factor. So I'm going to look for a GCF. So is there a number that can divide 8, 10, 12, and 15? So I'm going to start with the smaller number. I know 2 goes into 8, it goes into 10, it goes into 12, but 2 doesn't go into 15 evenly, so I can't pick 2. I know 4 does, but then 4 can't go into 10. 8 goes into 8, but it can't go into 10, so there's no number that can go into all of them. Let's check out the X's. This has an X, this has an X, this has an X, but this does not. So I can't do step 1. So step 1, I'm going to skip. The only GCF is 1. So when the only thing that goes into all of them is 1, we're going to skip the GCF step. Now step 2 is we are going to pair. So I'm going to pair these two together and these two together. And then I'm going to ignore these two here, and I'm going to look for what they have in common. So what can go into 8 and what can go into 10? Well, they're both even numbers, so I'm going to pick 2. And then they both have X, so I go with the one with the smaller exponent, and that is how I know what goes in the front. So then 2x times 4x, when I multiply these two together, 2 times 4 is 8. I have an x, I have another x, that would make 2. And then 2x times -5, when I multiply these together, I would get -10x. Now I'm going to come over here and I'm going to do these two here. So what can divide into 12 and 15? Well, 3 can. So that's how I know to put a 3. And because this one is positive, I'm going to put a plus there. And then they both don't have x's in common, so I'm just going to put a 3. So then 3 times 4 is 12. And then I need an x, so these two will multiply to get that. Now 3 times -5, 3 times -5 is a -15. Now if this works, and I did this correctly, these should match right here. This should match this. That's my clue that this is possible and that I did this correctly. So when these match, you're going to bring it down, 4x minus 5, and then you're going to put these two together. I don't care if these two together go here or if these two together go here. It doesn't matter. So I'm going to take the 2x plus 3. And then that would be my answer. And then, of course, if you want to check this and make sure this makes sense, this should all multiply out to get you this. That's what this is saying. I rewrote this problem as a multiplication problem. So if you're wondering, like, why? Like, what is this for? Why are we factoring? That's going to make a lot of sense when we do section 6.8. So stay tuned. We're learning a skill, and you're going to see what it's for when we do section 6.8. All right, so let's try another one. If you think you got it, then pause the video. So how do I know when to use this? When there are 4 terms, 1, 2, 3, and 4. So the first step is see if there's a number or a term, something that divides all of them. So is there something that goes into 5, 15, 1, and 3? No. Do they all have x's? No. So step 1, skip. I don't need to do the GCF step because there's no GCF other than 1. Now I'm going to pair them. So I'm going to put these two together and these two together. So I'm going to ignore these two here, and I'm going to just focus on these two, and I'm going to ask myself, what divides 5 and 15? And hopefully you're thinking 5. So that's how I know to put 5 in the front of the parenthesis. And then they both have x, so I take the one with the smaller exponent, and it goes here. And then 5x cubed, I need another x to make 4. And then 5 times -3 makes -15, and I already have 3. Okay, so if I multiply this out, I get this. Now I'm going to come over here and do these two here. So what divides into 1 and what divides into 1 and 3? So nothing does. So I'm just going to put a 1 because 1 goes into everything. And because this is positive, I'm going to put a positive. And then I'm going to put a parenthesis. And then I'm going to bring these down because when I distribute a plus sign through, positive 1 times x would make this. And positive 1 times -3 would make this. So when I multiply by 1, I get itself back. So 1 times x is 1x. 1 times -3 is -3. Now, if I did this correctly, these should match. And they do match. So then I'm going to bring that down. And then I'm going to put these two together. I could put them here, or I could put them here. Your choice. I'm going to go put them here. So I'm going to put the 5x cubed and the plus 1. Okay, let's go ahead and try the next example. So the very first step, how do I know that I could do these steps? Ask yourself that question. And hopefully you're thinking 1, 2, 3, 4. It has 4 terms. So then you're going to ask yourself, is there anything that divides into 3, anything that divides into 7, 6, and 14? Something that goes into the whole problem. That always goes first. Is there a number that goes into all of them? And the answer is it's 1. So I'm going to skip. The only number that goes into all of them is 1. So then the next step is to pair. So I'm going to put these two together and these two together. Again, you don't have to do that. You could do these two together and these two together. You got to pair them up. I always do the first two and the last two. So then I'm going to ignore this part. And I'm going to ask myself, what divides into 3 and what divides into 7? What number goes into both of them? And they have nothing in common. So I'm just going to put 1 because 1 can go into anything. And then they both have x's, so I take the smaller amount, so x squared. And then they don't have y's in common, so the only thing that's going to be in front of this parenthesis is x squared. So 1 times 3 is 3. And then I need 3 x's, so that's how I know to put 3x here. And then 1 times -7 makes -7. And I already have 2 x's here. But I don't have a y, so I'm going to need a y here. So again, when I multiply this through, I get these. Now I'm going to go do the same thing over here. So what goes into 6 and 14? Well, they're both even, right? 2, 4, 6, 8, 10, 12, 14. They're both even, so I'm going to pick 2. And because this is negative, I'm going to put a negative right here. And they both don't have x's, they both don't have y's. So I'm just going to put a -2 there. So then -2 times 3 gets me -6. So that's how I know to put a 3 here. -2 times 3 is -6. Well, I need the x because I don't have an x here. So I'm going to put an x here. And then -2 times -7 would make +14. So that's how I know to put -7 here. A negative times a negative is a positive. Now remember, when there's a negative in front of a parenthesis, it changes the sign. So instead of negative, it's positive. Instead of positive, it's negative. And then we don't have a y, so we need a y here. So when I distribute this, I get this. Now, if I did this right, when I move this paper away, these should match. And I'm like, awesome, yes. If they don't match, check. Maybe you did something wrong. And then I'm going to bring these down, the 3x minus 7y. And then I'm going to bring these down. It could go here or they could go here. So I'm going to have 1x squared. Remember, that's the same thing as just x squared. I don't need a 1 in front of an x. And then minus 2. And now I have that written in factored form.